Salutations and welcome to Space Time Continues. My name is Mary Louise Davey. Let's get going to space. As promised, our topic is generational ships, and we have a lot to talk about. Yes, we have to choose the form of propulsion, think a couple other choices through, and shame you can't talk with me, but I think I can read your mind, right? Before we go into any of, well, the main story, there are a few areas that I'd like to review. First, while it seems as if our space program is not all it could be, funding being, well, somewhat down, crazy ideas like, I don't know, making the planet livable, the Earth livable for the near and distant future really isn't quite a priority. Well, can't get any worse, can it? You just got to be thinking, I can't get off the planet, I can't stay on the planet and breathe, what am I going to do? Well, thankfully, you would be wrong. There are people planning to save mankind. There are people who they're going to be our saviors in the long run. As we speak, there are engineers and scientists and maybe, just maybe, an evil genius or two designing a self-sustaining ship that just might be our only hope. I'm talking about a self-sustainable spacecraft capable of interstellar travel. Of course, there are a lot of things to consider. In their purview is designing a space-based ecosystem. This cool and necessary project is partly funded by DARPA and NASA. The time frame this project's expecting? 100 years. Basically, the ship will be a space version of Noah's Ark, entirely self-sustainable, able to house the human population, or I'm guessing about a percentage. What is the name of this project? Project Persephone. And it should be theoretically able to achieve interstellar travel by 2112. The other two partners in this undertaking, Icarus Interstellar, you remember that from a few shows ago, and the Foundation for Enterprise Development. Now, I don't have the answer for the next situation, but I do recognize that it has to be figured out. That situation is sex and procreation in space, or another planet. Currently, when a male astronaut comes back from the ISS, where there are no outward changes in behavior and things like that, they might be shooting blanks. This goes on for a little while, and while eventually it works itself out, when they try for a baby, it seems to be a preponderance of females born. See, when they're at zero gravity, a condition known as spaceflight syndrome occurs. Now, this situation may highlight another concern: pregnancy in space. You see, when the astronauts come back, eventually they stop, as I said, shooting blanks, and females, a large number, are born to them. Now, it's not scientifically known that that is the reason for it, but got a better reason? It really hasn't been looked at that deeply, at least to my knowledge. So it gives a little bit of food for thought. After all, if we were to go to space, the entire human race as we know it, well, we need to know that it's actually going to continue. And they're not going to be able to continue unless they can give birth, but life always finds a way, right? Now, the reason there's no stats for women astronauts is twofold. One, they often have some eggs that they save before they go up as a precaution, because women are good like that. And also, they take the pill to suspend any activities. So, now we look to planning our trip. Let's plan on the TRAPPIST-1 system. TRAPPIST-1 is perhaps better known as 2 Mass J 230629280502285 and is an ultra-cool dwarf star. It's slightly larger and massive than the planet Jupiter. It's located 39.5 light years from Earth, located in the constellation Aquarius. And the reason why we've chosen this system is that it has 7 temperate terrestrial planets. They were detected orbiting the star, a larger number than detected in any other planetary system anywhere. A study that was released in May of 2017 suggested that tightly packed exoplanets avoid colliding with one another due to orbits that are harmoniously resonant, and as a result are stable for very long times. Now, there is another reason we have chosen this. Not only does it have 7 planets, but also 3 of them are in the, Goldilocks zone, the habitable zone. So, all right, so propulsion. Antimatter? Well, logically, we wouldn't have enough. If you recall from the show we did on propulsion, we can only boil a cup of tea, and that's after decades of making it. We don't know where to find more in the wild, so that would be a problem. And we can't make the quantities that we need, not yet. So, Now, if we look at the other ones, if you recall using nuclear pellets, doing all these different things, they all require something. Well, how about go with the Vasimir engines? So if we use the Vasimir engines and maybe deuterium, we can find deuterium all along the way because it's quantiful in space. I mean, it's everywhere. So that makes sense. Water is also plentiful, from frozen on planets to saltier versions existing in a near liquid state, like Mars. So we're good there. And we can gather anything needed for oxygen from either the water itself or SiO2, that's silicate oxide, which also is a compound found quite a bit in space. Okay, so we can breathe, we have water, we have motion. What else? Well, there is the problem of cosmic radiation and debris, both of which could end an interstellar journey, dead in its tracks. So to solve that problem, scientists would need to come up with some kind of electromagnetic shielding to go along with an extremely thick hull. There's a professor at Washington University that is developing a shielding based off of the Earth's magnetic shield, or actually it's based off of Jupiter's magnetic shield, which is much stronger than Earth's. Now, there are many other products similar out there, especially in our special products division. And I guess it comes down to which one of these would be the closest to perfection at the time we have to leave. Which one will we go, hey, that one will really block it. So, also probably, the big generational ship would be built out in space. So we would take shuttles to get there. So there we go. We got that part in hand. So a generational ship would have to be a whole society in a microcosm. It would need hospitals, schools, living quarters or apartments. Obviously entertainment, like a mall, some movie theaters, maybe a bowling alley, and parks, security force, definitely a judiciary. It would need to be able to provide food for its crew, actually for the masses, and that might require agriculture or aquaculture, and likely domestic animals, which would also be necessary when we get to where we're going and you want to form a colony. So it is therefore presents a major challenge, not just to engineers, but also to social scientists. How should the crew be selected and the environment structured to minimize interpersonal conflict? What size of population is optimal for it to remain committed to the single overarching project of colonizing a new planet without too much of a risk of self-destructive boredom or excessive narrowing of the gene pool? So, does mental health require that a quasi-natural environment be recreated within the ship? You know, trees, grass, perhaps undomesticated birds and small animals, and then maybe you'd have pets, dogs, cats. Well, in addition to the technological and social challenges confronting the designers of such ships, there are fascinating philosophical and ethical issues that arise. Speaking of the ethics of a project that requires the next generation to grow in circumstances that are, well, maybe a little less than ideal. A form of living that started way before they were even existed or thought of, that ensures that their options are very limited. Do we consider this ethical? Would it be ethical if there were no other choice? I mean, if you had to leave Earth or die. I mean, would it then be ethical? But would it be ethical if you left before the catastrophe happened? I mean, they're kids, so deal with it. Well, no matter what their training and their careers and everything would be pretty much chosen for them. Is that wrong? Or are those that get to choose spoiled? A generational ship can work, but it is important that the children born aboard can be trained to become the next generation of, say, the crew, well, everything actually. They will have little or no choice over what kind of life they pursue. At best, they will have a range of shipboard careers to choose between, like chef, gardener, engineer, pilot, and so on. Now, of course, some will be built on natural ability and some on what options were left. I mean, they will not be able to choose a life of contemplation or withdrawal into the priesthood or any of those type things. Some might be able to work in the service industry, and I mean, they're bound to be bars. I mean, wouldn't that be cool? Bars on board and restaurants or stores. But what will they use for money? Well, now there's all these little things, the minutia of planning this out, planning out the member lives. So, But children on board generational ships, well, in general, could actually be better off given the access to the medical care, better nutrition, education, given that so many these days are born into poverty. But they still will be locked into a project that they didn't choose. For example, in the United States, the Amish, well, they have the legal right to take their children out of schooling, early on, in order to limit their exposure to the different ways of life. Now, those of us who worry their doing so limits the children's right to choose, or to an open future, however you want to look at it, well, should be even more worried now about locking children into a much greater extent than dreamt of by the Amish. After all, I mean, adults can and do leave the Amish communities, but no one gets to leave a generational ship, at least not alive. And few or none will get to choose what role they play on board. It would all come down to having a standard of life that would be, on average, pretty good for the masses. Everybody would be to some extent reliant on the government or the governing class. But that's all part of the ethics involved. And as I said before, likely there was a reason for us leaving in the first place, and so that might make it actually very ethical. So, the living quarters inside the spaceship would require different thinking. Cubic meters are more relevant than square meters in space, where use of space needs to be maximized, and therefore the space inside a room would have to be ergonomically designed. Now, individual privacy could easily be accommodated. Since we wouldn't really walk, our legs would be used mainly for pushing. An artificial gravity rotation area, such as the wheel seen in the spaceship of 2001 and Mission to Mars, well, that would be needed to maintain the fitness of the space travelers' muscles and, bone density and, those problems that are experienced in space. Well, daily onboard activities would include spacecraft maintenance, both inside and out, which would be the cool part, food preparation, recycling, observing, and documenting all the astronomical phenomena that the ship would be passing by, and so on. The crew would need to consist of, at the least, an electrician, cleaner, plumber, farmer, computer technician, biologist, miner, medical doctor, astronomer, chemist, physicist, geneticist, and yes, a rocket scientist. So, social interaction obviously would be crucial for maintaining psychological balance. Study and creative mental exercises would also need to be incorporated into the astronauts' daily routines. The lessons for the children would come from digital encyclopedic libraries, science, history, philosophy, texts, great works of literature, language lessons, all would be included. Now, since life inside of a spacecraft could be rather monotonous, creative outlets would be greatly encouraged and an integral part of the routine. The astronauts might even create works of art, digital art or music. There'd be time for games with their fellow travelers. Maybe there'd be people making movies, I don't know. The driving philosophies of mankind, science, religion, offer no explanation for the mysteries of the ancient world that point to strong circumstantial evidence that the gods of the ancients were in fact visitors from outer planets. Religions deny the cumulative data from the ancient world, calling them coincidences and flights of fancy. Science, on the other hand, finds it impossible to stretch the consciousness and imagine a different evolution. Would we now be the gods? I mean, when we arrive on some distant planet, is it an enviable position? Given that human beings cannot travel at the speed of light or travel through wormholes, could the aliens, once having visited Earth, coming via generational ships perhaps? Large ships, city size, maybe small or large as a planet or an asteroid, housing groups of extraterrestrials that live and work and reproduce on these self-sufficient space vehicles? If such migrating space colonies existed, well, they would no doubt stop at habitable planets they come across, as well as those that could supply them with minerals, ores, other natural elements that they maybe need to survive. I don't know. Could Earth be one such cosmic stopover for traveling EBEs? And can humans use this idea as the foundation for future space colonies? So we had to start with a crew of adult astronauts, or would it be impractical for interstellar space travel? Well, I propose, maybe in order to best increase the time for the astronauts in generational space travel, that most of the initial crew would have to be very young children. Ideally, between the ages of 5 and 6. Now, I realize that sounds very young, but maybe we could add that to their life on the other side. I mean, think of it. They'd be shadowed for a while by adults and their older counterparts, and the thought of sending children into outer space shouldn't be so scary. I mean, it might be horrifying to some of you, but think of it this way. It's every child's dream to become an astronaut. Why not make their dream reality? Very early on in life. The children would be raised and further trained by the few adults who accompanied. And, well, those children would grow into adults and be able to care for themselves and their older counterparts, their children born and raised on board. So their children are born on the spacecraft, and by the time the original adult astronauts grew elderly, the children born and raised aboard the generational starships would consider their environment as perfectly normal. I mean, they didn't know anything else. They have not been exposed to an Earth or any of these things. This would virtually eliminate any potential problems with claustrophobia. Life expectancy on board the spacecraft would be drastically prolonged due to the unpolluted atmosphere and lack of chemically altered foods. I mean, come on, we've all got these. Now we're eating chemically altered food. So now we've been accustomed to this in the diets, but now their diets become accustomed to something else. Gravitational stress, UV radiation, other factors take a toll on human bodies on Earth, and they wouldn't exist for the crew. Some might live to be 150 years old, but look like they're 40. Only visible signs of age would be white hair. However, the astronauts, both young and old, would have to keep up a regular exercise routine in order to avoid problems that are associated with living in space. Problems such as, well, living in a weightless atmosphere. I mean, foods might also be modified to help maintain bone density. Conceivably, the first spacecraft to embark on such a voyage would have to be designed to fit tremendous numbers and sustain the passengers as well in order to maintain genetic diversity. Through several generations, when the astronauts begin producing new generations, a minimum of 10 individuals would accomplish this, but more would obviously be better because of the genetic variety. The larger pool would offer a lot. I mean, to avoid the stress of overpopulation, reproduction among crew members, that kind of have to be carefully planned. Given the nature of the voyage, interstellar migration, having a large frozen repository of plant seeds would be imperative. And FYI, we have just such a store up in between Norway and the North Pole. These seeds could be used on other planets, both to grow food and potentially for terraforming. This could be achieved through a process called vitrification. Originally used to make glass, vitrification has become a relatively new way to preserve living tissue at very low temperatures. Specially engineered, a small, lightweight freezer capable of sub-zero temperatures between negative 80 Celsius and negative 196, that's the boiling point of nitrogen, FYI, would be required in order to preserve these living data bank, this plant life, over hundreds of years, basically the entire journey. At these low temperatures, any biological activity, including the biochemical reactions that would lead to cell death, is effectively stopped, eliminated. Vitrification provides the benefits of conventional cryopreservation, but without the organic damage due to ice formation. When defrosted, seeds can still germinate to produce healthy plants. A spacecraft left Earth more than 3 centuries ago, bound for the faraway TRAPPIST-1 system. But time has no meaning. In space, it's just one day is pretty much the next day. We count our time from the moment the initial crew stepped into the spacecraft and took off. So in the meantime, 9 generations have both been born and died aboard a spacecraft. And the original astronauts, well, the ones with memories of Earth, they're no longer around. The voyage has included pit stops along the way to gather resources, asteroids, comets, maybe an ocean planet for deuterium. So we had to make several stops, but there have also been numerous new scientific discoveries. But alas, we find ourselves at our destination. We arrive at TRAPPIST-1. The TRAPPIST-1 system, our star charts have been reasonably accurate up until now, but once there, our instruments might detect many unexpected small objects, perhaps moons orbiting the planets we knew of, or a black hole, maybe, oh gosh, I don't know, something, a pulsar, something unexpected. Obviously, we're a tad surprised by these inaccuracies in our star charts, but we don't care, because we've found many small Earth-like planets at our destination. Our instruments are also able to detect small objects that look like asteroids orbiting these small planets. We must choose one that best suits our needs. From all of these small planets, one of them attracts our attention due to the presence of thin atmosphere with a similar mixture of gases to Earth. Since we don't yet know what to call it, we'll temporarily refer to this new world as Planet Earth 2. Inventive, no? Because this planet has less mass than Earth, the gravitational pull is also less. And on parts of the surface, our onboard instruments detect the presence of oxygen, silicon, magnesium, titanium, manganese, sodium, potassium, and calcium. It's enough to make us choose this planet for our first settlement. Before we use the limited energy that we currently have by sending expeditions to this planet, we first create dome-shaped ecosphere, basically little outposts that are on the asteroids that circle the planet. And by creating these outposts will now be our launching pads. They'll house our telecommunication stations, stock supplies, possibly even yield valuable metals, maybe minerals, through mining. The crew must work together to get this job done as efficiently and as quickly as possible. We first create outposts on the 2 asteroids orbiting the planet, sending more sophisticated probes down to the planet Earth 2, just to give us a better idea of what we're getting ourselves in for. And, well, we need to know what we need to establish a successful settlement, and it will become our permanent home. So we determine that we can terraform a portion of this planet without disturbing the existing ecosphere or ecosystem. Apart from the elements already detected in both the surface and the atmosphere, our instruments also show a lot of unidentified. Down below, we also see many meteor impact craters and a lot of small lakes with mauve color, mauve tint. Interesting, strange, and kind of amazing. All of our readings indicate that it's safe, so we go ahead and continue. We go on with our plans. Now, since meteor craters are ideal for mining, we've basically decided that we should create our first live colony on planet Earth 2 by building an enclosed dome, ecosphere, our first small town, over this crater, over one of the craters. Because the thin atmosphere, we have to use oxygen masks frequently, pretty much of the time actually, every 15-20 minutes or so, because we kind of get tired. We begin to think of creative ways that will solve the fact that there's not enough oxygen in this atmosphere. And while we will continue to use oxygen masks until we can grow, I don't know, enough plants or something to provide us with adequate oxygen, eventually our galactic explorers may look for ways to change the genetic makeup, to adapt to new worlds. For instance, on Earth, birds have lungs that allow air to flow through the lungs. from one side to the other, meaning that their lungs are capable of, they're being used with maximum efficiency. Humans only use about 1/2 of their lung capacity. So if we could genetically alter or engineer ourselves so that our lungs allow air to flow through, like the lungs of the birds, well, then we could easily live in such a thin atmosphere. Now, while prospecting the surrounding environment, we are astonished to discover that what we thought were mauve-colored lakes are actually silicon-based organisms that move like Earth's continents, so slow that their movement is difficult to detect. Human science has never encountered anything like them, and we patiently observe, document, begin to learn all about these fascinating new life forms. At the same time, we discover several new elements, not part of the known elements found on Earth's periodic table. So much of human science is no longer worked on planet Earth 2, and now the new scientific theories are based on the new discoveries that we've made here on this new world. And they just start to emerge, and we get creative and we get really into the new science. We begin by mining new discovered elements that allow us to create technologies that are so different and more advanced than any ever created or seen on Earth. By accident in zero gravity, we discovered how to create this new synthetic metallic alloy with this incredible strength, and it's lightweight. The properties are just becoming highly valued in domed ecosphere construction and space travel. A few generations have passed since we arrived on Earth 2, and having started with one domed habitat, we now have 10 habitats scattered across the planet. Earth 2 has really become something. Our diet has changed due to a new strain of genetically engineered plants that we created when we got here, of course. And the children are accustomed to taking short space trips, going off to this planet and that, these nearby areas, and just investigating. There's talk of sending expeditions to new areas of the galaxy. Most of us want to stay on planet Earth too, but others would like to explore other worlds. And so, eventually, we build a larger and better modular type spaceship that can take our people for additional light years. The new crew is better equipped, trained than the first generation that had plotted this journey from oh so far away from Earth. Since this trip is out of curiosity and not out of necessity, telecommunication relay stations and supply outposts are all getting set up along the way. New communication technologies will enable us to better keep in touch with these space voyagers than was possible certainly with the group that left Earth because, well, A, there was nobody behind, but B, they couldn't have. So more than 5 centuries ago, couldn't have happened. The planet the second generational spaceship reaches will be called Zion. As time goes by, the people on Earth too get word that life colonization was successful on the planet Zion. Eventually, descendants of the original on Zion, those become travelers. They build new generational spacecraft. And they also create exponentially settlements over here and over here on planets Haven, Shoreline, Westwood, Beta World, and New York. Like this, the entire galaxy would be colonized. In only a few million years, we're everywhere. With just a dozen generations having lived on different planets, the original weak humanoid has gradually changed into something else. We alter and we adapt to various new environments. In the future, the symbiosis of star travelers will be a blend of nanotechnology and organic matter into what would be called cybernetic life forms. The realization of cybergenesis. Our descendants are so different from how humans on Earth have evolved that they could easily be considered aliens, although aren't we really the aliens now? I mean, this isn't Earth 1. So, since we can't assume success for every mission, 2 generational spaceships are sent from Beta World to explore the possible colonization of a new planet we call Utopia. However, the life forms encountered on this planet are more advanced than on previous planets and expeditions. And so it presents new challenges. I mean, what happens if some of these life forms have enough intelligence to create a social structure of some kind, or some advanced tribal mentality? To explore the possible colonization of a new planet, Utopia. However, the life forms encountered on this planet, well, they're more advanced than on previous expeditions and present new challenges. What happens if some of these life forms have enough intelligence to create a social structure of some sort? Or even advance to tribal mentality? I mean, on planet Beta World, we have no choice but to land in a world dominated by predators and beings with tribal behaviors. Interfering with the evolution of a localized species, well, that kind of creates new issues in the life colonization plan. Either we stay and try and create a stable world, or simply replenish our supplies and go on. Well, the second option is much more safer in the long run, but while visiting this planet, we can't help but study the natives and, truthfully, pick sides. The cruelty on this primitive world forces some members, well, to kind of try and help out their side, the side that they've chosen. We protect them, and while we're readying our spacecrafts for another long journey, and we gather our supplies and we get all set, and we try to teach them how to survive better, better skills, and maybe it'll help. We only hope they can retain this knowledge, but the inevitable happens. And when we leave, our protected and newly domesticated natives are left to think and fend for themselves. What will happen to them? Some members of the expedition are really worried, about their newfound toys. Will they self-destruct in their own ignorance? Or allow themselves to fall victim to their predators? They could survive and advance if they successfully implement the knowledge we gave them during our visit. The incident on planet Theta produces a paradox, because we are now, falsely, revered by the original inhabitants as protective deities, gods. Spiritual rituals are being created around our presence, which has been transformed into, say the natives are now, they're building statues to us, and just self-responsibility comes as a shock to them. So, since they've become so accustomed to being guided by and taken care of by the gods, or us, in the time immediately following our departure, these spiritual leaders rise up and they try and maintain social stability by creating new rituals. In their futile attempts to bring the gods back, well, some of these rituals start to include imitating things that happen. Perhaps talking about our death and that we will be born again and we will come again. Building structures to us, mimicking the technology of the gods, completely ignoring the fact that we were flesh and blood beings. Well, when primitive cultures try to copy the technologies or practices of much more advanced cultures, they're referred to by anthropologists as cargo cults. This phenomenon began to be well documented on Earth 1 in the 20th century. And more than 100 cargo cults have been recorded worldwide. The outcome on planet Theta has made us question some of the ancient mysteries on planet Earth 1. Could there be a parallel between the gods from the sky described by the ancients and, well, what we experienced from the generational space travelers, as generational space travelers? I don't know about this. I mean, how do we interpret this going forward? How do we... It just really, the likelihood that primitive humans mistook space travelers for gods, it's a little more believable, a little more probable. If generational space travelers visited our world, they would most likely have created outposts on the moon. I mean, that only makes sense. Before you come down to the Earth, would you do the same thing we did when we found an asteroid up by Earth 2? So maybe we'll find structures on the moon, like in 2001 Space Odyssey by Arthur C. Clarke. Another interesting pragmatic theory for space colonization is presented by Marshall T. Savage in the book The Millennial Project, Colonizing the Galaxy in 8 Easy Steps. Now, since the galaxy, much less the known universe, has billions of stars, the probability of diverse life forms is not only plausible, but probable. Our own planet slowly drifts within the solar system, and basically going around the Milky Way galaxy, it has an incredible range of diversity. In this galactic soup, are we part of the past of ancient star travelers who dropped by on Earth? Or what if it's the other way around? Are we their future? Are they our past? I mean, there's a lot of paradoxes here. These paradoxical questions can help us rethink the meaning of alien intelligence. In this, a pattern emerges from the creation myths, which beings from the sky, although different, shared a basic genetic fingerprint, the humanoid form. The gods from the most enigmatic civilizations on Earth were just a variation of a humanoid that evolved in a very different planetary environment. Would they be EBEs? Are we EBEs? I don't know. So I'm guessing that you now, if not before, understand how life changes once we take that step. Once we leave this planet, for the more processes that become possible, the more we realize, the more we look at history differently. Humanity is now in every corner of the galaxy, no, the universe. I mean, from the moment humans started to fly, Earth was seen through different eyes. Lines on the ground, drawings of enormous scale that couldn't be seen from the ground before, all of a sudden, were now visible from the air. How did our ancestors carve the kilometers-long, unbroken lines and symbols, including animals, I believe, El Astronauta, on the vast plain of Nazca and other points all around the world? I mean, why did they create these lines? Why did they create these symbols? And why? What purpose? How did the ancients have the knowledge to construct the pyramids of Giza, the Teotihuacan complex in Mexico, the monument of Yanaguni off the coast of Japan, the Calasacia temple of Tiahuanaco in Bolivia, and many other mysterious structures scattered across the globe? Now, and they all fit together basically. It's all a big jigsaw puzzle. Type construction technique, that's some guy, who knows, right? Is there an all-connecting link? The answers to these questions are hidden in the mythologies left behind as traditions, writings, drawings of ancient cultures. And one story keeps repeating itself over and over and over again. Flesh and blood beings from the sky, from the heavens, descended down to earth, brought knowledge, peace, prosperity, for the most part. And, well, because of their technologically more advanced knowledge, these beings were falsely revered as gods. Eventually, they left. They just disappeared without any explanation. According to legends and traditions, these gods did not look all that different. They appeared humanoid. In the 20th century, unidentified flying objects, or UFOs as they're known, thought to be piloted by extraterrestrial biological entities, that's EBEs to you and me, became part of our popular culture. These modern EBEs have also a common physiological characteristic to the human species. They have a torso, 2 legs, 2 arms, neck, head. So the physical proportions of these vary certainly by species, the grays, the this, the that, whatever. But isn't there an interesting similarity between past, present beings continuously visiting our world and the human species? Many scientists reject the idea of extraterrestrials visiting Earth because of fear of ridicule by their peers, by us. But they also cannot see beyond current scientific ideas. The scientific ideas that make long-distance space travel possible. Common arguments from science are, well, beings can't travel at or near the speed of light, and the distances between star systems is way too large. I mean, come on, extraterrestrials couldn't possibly live long enough to travel here. Still, critics of those scientists, as well as science fiction writers, such as me, have hypothesized that extraterrestrials can travel either at the speed of light or through wormholes that would basically allow them to travel these great distances that they don't believe, the scientists don't believe in, and rather quickly. Now, how it is done, I don't know. But there are rarely mentioned technically feasible explanations for how EBEs could be coming to this planet. One possibility is that those beings have an incredibly long lifespan, by our standards anyway. For example, what if these EBEs lived the equivalent of 500,000 Earth years? Then spending 10,000 years traveling here, that's not really that much after all. Not too unreasonable. So, given that we know of species here on Earth that go from a couple of days, some insects, to thousands of years, which some trees obviously, the possibility that there are species in the universe that live hundreds of or thousands of millions of years, well, it seems a little more plausible, doesn't it? There is one other often neglected explanation of how beings that do not live quite so long but can travel so far, some aliens that want to get here but they live so far from us and they can't travel at the speed of light and they can't travel through wormholes. Maybe they visited Earth with generational spaceships. The basic premise behind generational spacecraft, well, it's that a large spaceship, city size, asteroid size, planet size, holds a group of extraterrestrials that live, work, reproduce, all of that stuff. Live, mostly self-sufficient space vehicles. Now, if migrating space colonies exist, they would no doubt stop at habitable planets as they come across, as well as, get resupplied, just the same way as we would while we travel out, so would they. So, I don't know, what do you think? Maybe the aliens also use generational ships? That seems quite possible. So we could use that as the foundation of forming our colonies. We can use that idea to expand beyond the boundaries of Earth, if we're to survive. Human DNA is only about 3% different from our closest relatives, the chimpanzees. Now, like most other organisms on the planet, we procreate and colonize to survive. However, that procreation and colonization can only continue for so long within the confines of the planet before we ultimately die from the poisons we've created by our culture, or from an asteroid, or climate change, loss of oxygen, and so on. The possibilities are literally endless. We would also have to discover ways to overcome the traditional obstacles that come with space travel. UV, i.e. radiation, dust particles hitting spacecraft at speeds so great, well, they can act as mini bullets. Solar winds, etc. A radiation shield could, for instance, be the combination of gold-tinted glass or polymer with a layer of water which would absorb most of the radiation particles. The road to deep space Well, living in space could be easier than one might think. In fact, technology exists today that could make such a cosmic voyage feasible. Simplicity and efficiency would be keys to the success of such a journey. Life would become very basic. Food, water, oxygen, the bare essentials. It would have to be even more so for us to contemplate a mission to the nearest star, say Alpha Centauri, a mere 4.3 light years away. The journey looks intimidating because of the distance, but it's not that far. So obviously, it's all go around. I mean, we travel out, we become gods to someone else, and light bulb goes on and we say, oh my gosh. So maybe it's just the general way things go on and on. So generational ships, they might just be our future. They might be our only future. Elon Musk is right, and the many others that think so. We need to get off this planet, and we need to plan ahead for getting off of this planet. So, food for thought. In the meantime, I'm going to see you next time when space-time continues. Keep thinking.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, go for main engine start, 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
Speeds and injector pressures look good. HER roll program has begun. Body rates look good. Booster engine continues to look very good. Pump speeds and injector pressures in band. Continues to perform well. Now requesting an acceleration change. Booster has begun the zero angle attack phase of flight. Pictures look good. Body rates